It begins with silence. No bang, no fire, no scream, just silence. Somewhere in the unimaginable future, the last star in the universe flickers and dies. Its final photons escape into the cold, eternal dark. They travel endlessly, with no eyes to see them, no planets to warm, no life to cherish the warmth. This is how the universe ends. But to understand how we got here, to this cosmic blackout, we must go back. Not just billions of years, but trillions. Back to when light was young. In the beginning there was only darkness. Then came the Big Bang, a singular flash, birthing time, space, matter, and energy. And with it came light. In those first chaotic moments, the universe was too hot, too dense, but as it expanded, it cooled. Atoms formed, then hydrogen, the simplest and most abundant element, gathered into clouds. Gravity worked slowly and patiently, pulling this gas together. Eventually, pressure and heat ignited the first stars. These were not stars like our sun. They were massive, blue, short-lived giants, luminous and violent. Their lifespans were measured in millions, not billions, of years. And when they died, they went supernova, scattering heavier elements across the cosmos. The ashes of their deaths gave birth to new stars, smaller, longer-lasting ones. Red dwarfs, yellow suns, complex molecules, dust, and eventually, planets. This was the stelliferous era, the age of stars, a brilliant star-studded epoch stretching over trillions of years. Look up at the night sky today. Every twinkling dot is a star born of that grand process. Some host worlds, some are dead, others are just beginning their journey, but they all speak of a universe still alive, still burning, and with stars came everything else, planets with oceans, moons with ice, clouds of gas and dust painting galaxies like masterpieces. The universe was not just expanding, it was living. Light raced across space, bouncing off comets, lighting up rings of Saturn, getting trapped in chlorophyll on a blue planet called Earth. For now, we are in the prime of the stelliferous era. But this brilliance is not permanent. The fuel that powers stars is not infinite. Every fusion reaction eats away at that supply. And eventually, the stars will begin to fall. Not all at once, but inevitably. And then comes the silence. Stars live by burning hydrogen into helium. As they age, they burn helium into heavier elements until they can no longer maintain the fusion reactions at their core. When a star exhausts its fuel, it dies. How it dies depends on its size. Small stars, like red dwarfs, fade gently into white dwarfs, cooling over trillions of years. Medium stars, like our sun, become red giants, shedding their outer layers before settling into white dwarfs. Massive stars end in spectacular supernovae, leaving behind neutron stars or black holes. But here's the issue. Stars recycle hydrogen from the gas and dust around them, but over time, that gas gets locked away. It becomes part of stars, planets, or is ejected into intergalactic space, too far from any gravity well to ever be recovered. Eventually, no more stars will form. This is not science fiction, it's astrophysics. We already observe a decline in star formation in galaxies, including our own Milky Way. Star birth is slowing. At some point, perhaps 100 trillion years from now, it will stop entirely. The universe will become a cemetery of stars. One by one, stars will go dark, galaxies will dim, nebulae will vanish, the brilliant tapestry of the cosmos will unravel. Imagine watching the lights of a city switch off street by street, first the towers, then the neighborhoods, then the houses, until you're alone in the dark. That's the fate of the universe, but it gets darker still. Let's travel far into the future. A trillion years from now, a lone red dwarf, the longest living star type in the universe, burns its final hydrogen atom. Its light dims, its warmth fades, No planets orbit it anymore, no life depends on it, and no one is there to see it die. It quietly becomes a black dwarf, a theoretical object we've never observed because the universe isn't old enough. But in this distant future, black dwarfs fill the universe, cold, invisible, and silent. No star remains to rise. The stelliferous era ends, and now begins something far more alien, the degenerate era, an age of remnants, the corpses of stars, white dwarfs, neutron stars, and black holes. These are no longer stars in the traditional sense. They don't shine, they don't burn, they simply exist. And among them, the kings of darkness begin to rise. Black holes are the most terrifying entities in the cosmos. They consume matter with no remorse. Not even light can escape. They are the vacuum cleaners of the universe. In this new dark age, black holes take over. They feast on the leftover corpses of stars. They merge with each other. Supermassive black holes devour entire galactic cores. Imagine galaxies colliding, not with sparks, but with silence. Two black holes spiraling into one another. The gravitational ripples from their union echo across space. And yet, even black holes die. In 1974, Stephen Hawking proposed that black holes aren't completely black. They emit a tiny amount of radiation, now called Hawking radiation. It's slow, unfathomably slow. A black hole with the mass of our Sun would take 10 to the power of 67 years to evaporate. A supermassive black hole? Try 10 to the power of 100 years or more, but in time even the greatest of them will fade. With a final whisper of heat, the last black hole will evaporate into nothing. And then, there is nothing left to burn, nothing left to collapse. No gravity wells, no stars, no galaxies, no atoms, only particles. Welcome to the dark era. There are no stars, no planets, no heat. All that remains are subatomic particles, electrons, photons, neutrinos, drifting endlessly through an expanding void. Space stretches so wide that particles rarely, if ever, interact. Entire light years of vacuum separate single particles. Temperature drops asymptotically toward absolute zero. Entropy, the measure of disorder, reaches its peak. Nothing changes. No clocks tick. Time becomes meaningless. The universe is not dead. It's just finished. No observer remains to ask questions. No eyes to gaze. No mind to wonder. Just silence. An infinite, eternal silence. This future is bleak. But could anything survive? Some theorists speculate about ultra-advanced civilizations who delay their extinction by using black holes as power sources. They might slow down time from their own perspective. Use energy only when necessary. Hibernate for millions of years, waking for only microseconds. Or maybe consciousness itself could be encoded in patterns of subatomic particles, sustained by their rare moments of interaction. But this is science fiction. There is no evidence for it, and the universe offers no favors. Eventually, every bit of usable energy will be gone, and life, even artificial life, will cease, not with a bang, not with a scream, but with an eternal exhale into nothingness. Is this really the end? Some scientists think maybe not. The universe could experience a big bounce, a contraction followed by another big bang. Or perhaps quantum fluctuations in the vacuum could spark new universes. The multiverse hypothesis says we might be one of countless universes, each born in its own fire, living and dying like cosmic bubbles. If so, maybe our universe's death is just one page in an eternal book. But even if new universes arise, this one, our home, will never be reborn. Its fate is sealed. Why should we care? Because we live in the briefest flash of time when stars still shine. We have warmth, we have light, we have thought. We can ask questions like this. We can marvel at the stars. We can tell stories. This is rare. This is precious. We are alive during the cosmic spring, before the long winter arrives, and knowing how the universe ends doesn't diminish its beauty. It enhances it. Like a sunset you know won't come again. So when you look up at the stars tonight, remember, they won't always be there. And yet, they are here now. You are witnessing a miracle, a fleeting brilliance in a universe destined for darkness. And in this sliver of time while the stars still burn, we get to shine too.